I have burned Instagram accounts in almost every way possible, spent money on proxies that did nothing, watched accounts I spent weeks warming go dark overnight, and the frustrating part was that most of the advice online was missing the actual explanation. Use a proxy, fine. But which kind, configured how, and why does it matter at the IP level? Nobody explained the mechanism, so that is what this video is. 2 years of running 10 plus Instagram accounts in parallel, some for clients, some for content, a couple for storefronts. Here is what I actually learned. Why Instagram bans multi-account operators? Let me start with what is actually happening when Instagram bans you. It is not magic. It is not a human reading your profile. It is automated pattern detection running across hundreds of signals simultaneously. Instagram's anti-abuse systems exist because fake engagement farms, spam operations, and coordinated inauthentic behavior are real problems on the platform. The same detection logic that catches spammers also catches legitimate multi-account operators who happen to look like spammers from a signal perspective. And that distinction matters. You are not being hunted personally. You are being caught by a pattern. What the system looks for is correlation. Accounts become suspicious not because any single signal is wrong, but because multiple signals are correlated in ways that suggest a coordinated non-human operation. Two accounts posting at the same cadence, from the same IP, on what appears to be the same device, following the same 200 people in the same order. Instagram does not need to know what you are doing, it just needs to see the cluster is unusual. Meta has meaningfully increased the aggressiveness of its detection in the last 18 months. Action blocks now trigger at lower thresholds. In 2022, you could follow 200 accounts per day on a new account. Today, 80 follows on day one is enough to trigger a block on many setups. And account clusters are being actioned together, not individually. If 3 accounts in your setup get linked by IP or device, all 3 get targeted when any one trips a signal. This is the most expensive failure mode and the one that blindsides people. The 3 things Instagram actually fingerprints. There are 3 signal categories that drive most bans. I want to name them clearly because the rest of this video only makes sense once you understand all 3. The first is device signals. Through the native app, Instagram sees your device model, Android or iOS build version, advertising ID, unique device identifier, and touch event patterns. Through a browser, it collects user agent, screen resolution, fonts, the output of a hidden canvas element, WebGL renderer strings, audio context, fingerprints, time zone, language. All of this hashes into a fingerprint that is unique or near unique per real device. Real humans have a consistent fingerprint across sessions because they use the same device. Multi-account operators often use the same device for multiple accounts, and the accounts become correlated. The second is network signals. Every connection to Instagram exposes your IP address, the ASN that owns it, the organization behind that IP range, and behavioral signals at the network layer. Beyond the raw IP, Instagram can see whether multiple accounts are being accessed from the same IP in the same session window, how many accounts have historically been tied to this IP and what happened to them, and whether the IP type matches the device type being claimed. A mobile device claiming to be iOS but connecting from an Amazon IP is an incoherence the platform sees. The third is behavioral signals, follow and unfollow velocity, the time distribution of actions across the day and week, DM initiation rate to accounts that do not follow back, posting cadence, especially whether multiple accounts post at identical intervals, login frequency, session length, engagement ratios. These are the hardest to fake convincingly because they require modeling real human behavior. Even on a perfect IP with a perfect device fingerprint, an account that sends 50 DMs per hour to strangers will get action blocked. I will give you specific numbers later. Most operators get caught because they fix one layer and ignore the others. A perfect mobile IP with a burned device fingerprint still gets flagged. A clean device fingerprint on a data center IP still gets flagged. The system sees all 3 simultaneously. The network layer, everyone gets wrong. Most people buying proxies for Instagram are buying the wrong kind. The difference is not just price, it is fundamentally how the IP is perceived by Instagram's reputation systems. Data center proxies come from servers at Amazon, Google Cloud, OVH, Hetzner, and similar. These IPs have never had a real human Instagram user. The ASNs have extensive reputational history with Instagram, specifically a history of abuse and fake engagement farms. Instagram applies much higher scrutiny to actions from data center IPs, and accounts living there have shorter lifespans and lower action limits. If you have had a fresh account hit suspicious activity within hours while using a data center proxy, that is why the IP class itself is a red flag before you do anything. Residential proxies are real consumer IP addresses from real home ISPs. They look like real users at the IP level because they are real users' IPs. The problems for Instagram specifically are three. Shared history. The same IP has been used by thousands of operators before you, and if any ran spam, the IP carries that. Rotation. Residential pools rotate IPs between sessions, and an account that logs in from a different IP every session looks suspicious because real users do not behave that way. No carrier reputation. Residential IPs do not carry the specific trust signal that mobile carrier IPs do on Instagram. Mobile proxies route traffic through actual mobile devices on actual carrier networks. Your exit IP is a real mobile carrier IP assigned via carrier-grade NAT. This is qualitatively different from the other two in ways that directly matter for Instagram. Why mobile IPs beat everything else for Instagram? Mobile carriers use carrier-grade NAT, which means thousands of real subscribers share the same public IP address. From Instagram's perspective, seeing 50 accounts logged in from a single mobile carrier IP is not suspicious, because that is what actually happens when 50 people on the same carrier share a CGNAT block. It is normal. Instagram has calibrated its thresholds around this reality. This is the structural reason why mobile IPs tolerate more account density than residential or data center IPs. Your accounts blend into a baseline set by thousands of real users. Mobile carrier ASNs have very different reputational profiles from data center ASNs. A carrier like Singtel, StarHub, or M1 in Singapore has an ASN that is predominantly real consumer traffic. The abuse rate from mobile carrier IPs is lower than from data center IPs, not because mobile operators are morally superior, but because it is harder to run large-scale abuse on mobile carrier infrastructure. Instagram's internal scoring reflects this. I have personally seen the same account creation fail immediately from an OVH IP and succeed without any friction from an M1 IP. Same device fingerprint, same behavior, different IP class, completely different outcome. When my traffic exits on a real Singtel or M1 or StarHub IP, Instagram sees a Singapore mobile carrier, ASN, a network class consistent with the device reporting itself as Android or iOS, no prior abuse history on this specific IP because it is dedicated, and CGNAT behavior that is normal for a mobile network. A quote-unquote mobile proxy that routes you through a static data center IP with a mobile carrier label is not the same thing as an actual mobile network IP. The former can be detected, the latter cannot because it is real. For accounts targeting Singapore audiences, there is an additional reason. Some of Instagram's regional content decisions correlate with the apparent location of your IP. An account that has always accessed Instagram from a Singapore carrier IP looks like a natural Singapore user, which matters for reach and local content recommendation. One more distinction: dedicated versus shared mobile proxy. A shared mobile proxy means multiple customers using the same port. The exit IP's history includes all their actions and you do not know what they have done. A dedicated mobile proxy means one port, one customer, one account. The IP's recent history is entirely yours. For Instagram account work, dedicated is not optional. The cardinal rule: one dedicated proxy per account. This is the single most important operational rule in this entire video. Write it somewhere, you will see it. One dedicated mobile proxy per Instagram account, always. Not one proxy per device, not one proxy per batch. One proxy per account, permanently assigned, never reassigned without deliberate planning. The reason is Instagram's session to IP memory. When an account logs in from IP A, then later from IP B, then later from IP A again, Instagram sees that. If IP A and IP B are both associated with other accounts, the correlation strengthens. If the switch happens frequently, It looks like account sharing or a rotating proxy. Both are suspicious patterns. A real human user logs in from their phone's IP, which may change slightly as they move between towers, but it stays in the same carrier's address space. It does not jump from Singtel to DigitalOcean to a US residential IP across 3 sessions. Mobile proxies offer 2 modes. Sticky session holds one IP until you manually trigger a change. Every connection through the proxy exits from the same IP. This is what you want for Instagram accounts. The account sees a consistent IP behavior, looks like a real user on a real phone. Rotating proxy assigns a different IP per request or per session. This is useful for scraping and data collection, where you need to distribute requests across many IPs. It is actively harmful for Instagram accounts because constant IP changes are not how real users behave. The only time you rotate an Instagram account's IP deliberately is when you have a specific reason. The current IP got burned by a prior operator and you want a clean one, or you are retiring and rebuilding an account. You do not rotate for safety. You do not rotate on a schedule that manufactures exactly the instability signal you are trying to avoid. If you are getting unexplained challenges on what you think is a clean mobile IP, check whether you are on sticky or rotating. This single mistake accounts for a large percentage of the "my mobile proxy is not working" complaints I see from operators who actually just bought a rotating pool and wondered why Instagram treats their accounts like they are jumping around. The device layer: cloud phones versus anti-detect browsers versus real phones. Fixing the network layer without fixing the device layer gets you halfway. Here is the honest comparison of the 3 main approaches. Real phones are the cleanest option in terms of signal authenticity. A real Android or iOS device has a genuine device fingerprint, real hardware characteristics, and native app behavior. Instagram's app-level detection sees exactly what it expects to see from a real device. The downsides are real. Cost: each device is $200 to $600. Physical management overhead and scale limits. If you are running fewer than 5 high-value accounts where bans are extremely costly, real phones are worth the investment. Anti-detect browsers: Go Login, Multi-Login, Ads Power, Octo Browser create isolated browser profiles where each profile has a spoofed fingerprint, distinct user agent, canvas fingerprint, WebGL renderer, time zone, language, fonts. The advantage is scale. You can run dozens of profiles on one machine. The disadvantage is that Instagram increasingly detects browser-based access patterns that do not match what the native app produces. Anti-detect browsers work best for management tasks, checking stats, replying to DMs, scheduling posts. They are less reliable for high-activity operations on fresh accounts. Cloud phones emulate real Android devices in a cloud environment running the native Instagram app. The quality of the emulation matters enormously. A well-configured cloud phone that passes Android integrity checks is considerably harder for Instagram to detect than a browser profile. A poorly configured emulator that fails Play integrity checks or reports obvious emulator strings will get caught. Instagram can check Play integrity verification at the API level. A cloud phone that fails device integrity can be flagged. WAM current setup uses cloud phones for high-activity accounts and anti-detect browser profiles for lighter management tasks. The cloud phone plus dedicated mobile proxy combination hits the best practical balance of authenticity, cost, and scale. Cloud phones run around $5 to $30 per profile per month. Pair that with a dedicated mobile proxy and you are close to a real device at manageable cost. The DNS leak nobody explains. This is the one that catches experienced operators off guard. You have a clean mobile IP, a clean cloud phone, proper account separation, and you are still getting flagged in ways that suggest Instagram knows your real location. The culprit is often DNS. When your device or browser needs to resolve a domain name, it sends a DNS query to a DNS resolver. By default, this resolver is configured at the operating system level, not at the proxy level. So even when your traffic is being routed through a proxy, your DNS queries can be going directly to Google's resolver or your ISP's resolver, bypassing the proxy entirely. Instagram does not directly see your DNS queries, but they reveal your real network location in indirect ways. If your IP says Singapore but your DNS resolver is resolving from a US IP, downstream services can see this mismatch. Some platforms correlate the geographic origin of DNS queries with the origin of the traffic. Browser-based DNS over HTTPS implementations can route DNS separately from the SOX5 proxy. So even if your main traffic is routed correctly, DNS can still leak your real location. The fix is to use SOX5H mode, not plain SOX5. In plain SOX5 mode, DNS is resolved locally before the proxy receives the request. In SOX5H mode, the proxy resolves DNS remotely at the exit point. So the DNS queries appear to come from Singapore, not from your machine. In anti-detect browser profiles, look for a setting called proxy DNS or remote DNS and enable it. In Go Login and Adds Power, this is a checkbox in the proxy configuration panel. In cloud phones using a proxy app like ProxyDroid or SoxDroid, enable remote DNS in the proxy app settings. Some cloud phone setups support a VPN-level configuration that tunnels DNS at the system level, which covers every app on the device. The simple test: with your proxy active, visit dnsleaktest.com. The DNS section should show servers geographically consistent with your proxy's exit location. If it shows your real ISP, you have a leak. Fix that before attaching any account to this setup. If you are getting unexplained challenges from accounts that otherwise look clean, DNS is the first place to check. Account warning: the first 14 days. A clean IP and device fingerprint do not make an account trustworthy in Instagram's view. Trust is built through a history of human plausible activity. A brand new account that immediately starts following 100 people, posting twice a day and sending DMs is a pattern that real new users almost never exhibit. The warming process builds that trust history deliberately. The goal is to have your account pass the 14-day window that seems to be the threshold for most detection systems. Accounts that survive 2 weeks of low-key activity with no flags are significantly less likely to face action blocks on normal operations afterward. Days 1 through 3. The baseline. The most important thing is that the account's first network event, whether that is account creation or first login, happens through the correct proxy. If you create the account on your real IP and then switch to the proxy, you have already created a session to IP mismatch that starts the account with a negative signal. Create the account through the proxy, set up the bio, the profile photo, and one post on day 1, then leave it alone. Browse passively for 20 to 30 minutes. Scroll the feed, watch reels, do not interact. 0 follows, 0 DMs. Days 4 through 7, light engagement. 10 to 15 follows per day, maximum 50 total by end of week 1. 20 to 30 likes per day, 2 to 5 comments, 0 DMs. Keep session duration realistic at 20 to 40 minutes per day with variance. A session that is exactly 30 minutes every day with no variation looks like a scheduled script. Vary the length by 20 to 30% day to day. Days 8 through 14. Ramp toward normal. 30 to 50 follows per day. Spread throughout the day, not in a burst of 30 in 5 minutes. 50 to 80 likes. 5 to 15 comments. DMs only to accounts that follow you back, and only a handful per day. By the end of day 14, the accounts should have a coherent follow-to-following ratio and a content history that matches its apparent purpose. What to avoid regardless of which day you are on. Follow-unfollow cycling on the same accounts is one of the most reliably detected patterns on Instagram. Mass following in one burst looks different from the same count spread across 4 hours, and Instagram can tell. Using the same 30 hashtags on every post is a pattern. Copy-paste captions across multiple accounts that share any signal is a coordination marker. Logging in from multiple devices simultaneously is flagged immediately. The one rule that consistently catches people: they create the account on their real IP for even 10 minutes before setting up the proxy. Those 10 minutes create a session event from the real IP. The account now has a location mismatch baked in from its first moment. Do not do that. Behavioral limits that trigger action blocks. After the warming period, here are the limits I stay within for running accounts actively. These are empirically derived from my own setups, not from official Instagram limits which do not exist as public documentation. For follows and unfollows, On accounts 0 to 14 days old, 10 follows per hour maximum, 40 to 50 per day, and 0 to 10 unfollows per day. On accounts 15 to 30 days old, 20 follows per hour, 80 to 100 per day. On accounts 30 to 90 days old, up to 40 per hour, 150 to 200 per day. On accounts 90 plus days old, 60 per hour, 200 to 250 per day. The hourly rate matters more than the daily total. Even if your daily count is within the limit, doing 100 follows in 30 minutes will trigger an action block. Spread them across the full day with genuine-looking gaps, not uniform 6-second intervals. The timing distribution is one of the signals Instagram uses to distinguish humans from automation. Direct messages are the highest risk action category. Instagram treats unsolicited DMs as potential spam aggressively. On accounts under 30 days old, 0 to 2 DMs to non-followers per day, 5 to 10 to followers. On accounts 30 to 90 days old, 2 to 5 DMs to non-followers, 15 to 20 to followers. On accounts 90 plus days old, 5 to 10 to non-followers, 30 to 40 to followers. The non-followers category is where most action blocks happen. If you are sending DMs to accounts that do not follow you back, treat each one as a significant risk event on a young account. Posts and comments are relatively forgiving. Up to 3 posts per day on most accounts, 5 on well-aged accounts. Comments up to 30 to 60 per day on accounts older than 90 days, 10 to 20 on accounts under 30 days. Likes up to 300 to 500 per day on aged accounts, 50 to 100 on accounts under 30 days. One behavioral pattern that is underappreciated is login frequency. If you are logging in and out of an account 10 times per day because you are switching between accounts in a management tool, Instagram notices. Each login is an event, and frequent logins look like account sharing. A real user's phone is logged in continuously, with sessions being passive most of the time. Stay logged in. The exact stack I run. Here is the concrete setup I use for a 10-account operation. I am describing this in full because the gap between I use a mobile proxy and I have a working setup is where most people get stuck. For proxies, one dedicated Singapore mobile proxy port per account. Each port is on a real Singtel or M1 SIM 4G connection, sticky session by default. For device layer, cloud phone service for 8 of the 10 accounts. The 2 highest value accounts run on real physical phones. The cloud phone provider passes Play integrity checks and supports custom Android builds. For management, adds power for scheduling and metrics, but the cloud phones themselves run the native Instagram app, not a browser. For record keeping, a simple spreadsheet mapping account username, proxy port number, proxy credentials, cloud phone instance ID, creation date, and current status. 1 row per account. Not glamorous but absolutely essential at any scale beyond 3 accounts. The sequence for each new account is non-negotiable. Provision a new dedicated proxy port. Configure the proxy on a new cloud phone instance. Verify the proxy exit IP by visiting IP info. I/O in the cloud phone's browser and confirming a Singapore mobile carrier. Singtel M1 or StarHub, not a hosting company. Then create or log into the Instagram account from that cloud phone through that proxy. Record everything in the registry. There is no "I'll set up the proxy later." That creates a mismatch in the account's session history before you even start. I do not use third-party automation tools for growth actions on the accounts I care about. They produce behavioral patterns with uniform timing and sequential targeting that do not pass detection even on a clean IP. What I automate: posting schedules via the official Instagram API with proper rate limiting, analytics collection, and simple monitoring. Follows and likes I do manually in short focused sessions. Configuring a Singapore mobile proxy for Instagram. Here is how the proxy configuration actually works. On an Android cloud phone, use a proxy app like ProxyDroid or SocksDroid rather than the system Wi-Fi proxy, because Android system Wi-Fi proxy does not support username and password authentication in all versions. Enter the host port, username, and password. Set protocol to SOCKS5. Critically, set DNS to remote mode SOCKS5H so DNS queries route through the proxy and not from your real network. Enable route all traffic. Before logging into Instagram, open the browser on the cloud phone and visit ipinfo.io. Confirm the org field shows Singtel, M1 StarHub, or a real Singapore carrier, not a hosting company. In Go Login, set proxy type to SOX5 and enable the Use Proxy for DNS checkbox. Set time zone to Asia/Singapore, language to English Singapore, and geolocation to Singapore coordinates. In Ads Power, same principle, SOX5 with proxy DNS enabled, Singapore time zone, and disable WebRTC in the fingerprint settings. WebRTC can expose your real IP through a mechanism separate from DNS leaks. To verify you are on a sticky session, make 2 requests through the proxy 10 minutes apart and compare the exit IP. They should be identical. If they differ, check your port configuration and confirm it is set to sticky mode. After any deliberate IP rotation, keep activity light for an hour or 2 because the account will see a new location event at the network level. Ban recovery and the troubleshooting matrix. When something goes wrong, the fix depends on what type of block you are seeing. A soft action block, where Instagram says we restrict certain activity when you try to follow or like or DM, is almost always velocity too high or a too young account. The fix is to stop all actions for 24 to 48 hours and reduce velocity going forward. Do not rotate the IP. This is not a network problem. A hard action block with no time given usually means repeated violations after a soft block was ignored. Full stop for 72 hours, then RAM from near zero. Checkpoint required at login means Instagram saw an unfamiliar device or IP and is requiring identity verification. Complete the checkpoint from the same proxy and device that triggered it. Do not switch proxies mid-challenge. Completing a challenge from a different network context than where it originated can result in a harder lock. A shadow ban, where your posts are visible to you but invisible in hashtags and Explore, is usually caused by hashtag spam, banned hashtags, or automation signals detected at the content or request level. Remove suspect hashtags, stop any automation on that account, and wait 2 weeks. The shadow ban is behavioral, not network. Rotating the IP does not fix it. 2 accounts banned simultaneously while on different proxies is a cluster ban. The accounts were linked by something other than the proxy. Most common causes: both accounts were created from the same real IP before the proxy was configured. Both used the same recovery email or phone number. Both were operated on the same cloud phone instance at different times, creating a shared device fingerprint event. Check the registry for any shared attribute between the 2 accounts and fix it before rebuilding. Do not rotate the IP to solve a behavioral block. A new IP does not reset behavioral scoring, and an unexpected IP change after a block looks like evasion. Rotate only when you have confirmed the IP has a history problem, which you can test by creating a throwaway account on the same proxy and seeing if it gets flagged immediately without doing anything wrong. Always add a recovery email and phone number to accounts during the warming period. When a login from new location alert triggers, the verification flow is simple and the account is not harmed. Without recovery info, a security lock can become a permanent disable. How many proxies you need and the cost math. The basic formula is simple. Proxies needed equals number of accounts. 1 dedicated proxy per account, no exceptions. For a 10-account operation, using dedicated Singapore mobile proxies at $30 to $40 per port per month, cloud phone service at $10 to $15 per profile for 8 profiles, 2 real phones amortized at about $17 per month each, and a management tool license at $50 to $100 flat, you are looking at $460 to $650 per month. That is $46 to $65 per account per month. The alternative that seems cheaper: shared proxies at $5 a month, 1 anti-detect browser license at $30, run everything from 1 machine, total around $80 per month. But the ban rate is high, account lifetime is short, and you spend 20 plus hours per month on recovery and reconstruction. An account that gets banned costs you the infrastructure, the warming time, the content investment, and the follower base. The math on the proper setup stops looking expensive once you factor that in. For 50 accounts, dedicated mobile proxies run 1,500 to 2,000 per month. 50 cloud phone profiles add 500 to 750. Management tool adds 100 to 200. Total around 2,100 to 2,950 per month, $42 to $59 per account. If each account generates agency revenue, affiliate commissions, or e-commerce sales, that cost pays for itself. At 50 accounts, the registry and mapping discipline is not optional. A mistake in the proxy to account mapping can accidentally create a cluster and result in 5 to 10 simultaneous bans. I have seen operators at that scale lose weeks of work in an afternoon because they let a registry drift. Account age compounds too. Age unlocks Instagram shopping eligibility, Reels bonuses, affiliate commission programs, and higher initial reach from the algorithm. An account that survives its first year without bans is worth dramatically more than one you rebuild every few months. The proxy cost is the cost of protecting that compounding value. The CTA, try a real Singapore mobile proxy. If you have made it this far, you understand the full picture. The network layer is one of three. Device and behavior are the other two, and those are yours to manage through your cloud phone configuration and your action pacing. But the network layer is the part you can buy, and getting it right removes the most common and most invisible source of bans that most operators never diagnose. I want to be honest about what a proxy actually does and does not do. A dedicated Singapore mobile proxy removes the IP-level red flag from your account setup. It ensures the network layer of Instagram's fingerprints looks like a normal Singapore mobile user rather than a data center, a burned residential pool, or a rotating address that changes every session. Most operators who get banned repeatedly are getting banned partly because of this layer. What it does not do, it does not make your accounts immune to action blocks from behavioral violations. It does not protect accounts that share a device fingerprint. It does not substitute for the 14-day warming process. It does not help if your cloud phone is poorly configured and leaking automation signals. You need all three layers, network, device, and behavior, to be clean simultaneously. Fixing one while ignoring the others gets you halfway, and halfway does not keep accounts alive. What I can tell you from running this for 2 years, once you get the full stack right, accounts live a long time. The bans I still get are from behavioral overshoots where I pushed velocity too hard, and those are narrow, soft, and recoverable. The random hard disables from suspicious activity that plagued my early setups essentially stopped once I moved to dedicated mobile IPs with proper device isolation. The place to start is SingaporeMobileProxy.com. There is a free trial that provisions a real dedicated port in minutes. Real Singapore Mobile Carrier IP, Singtel or M1, sticky session, DNS routed through the tunnel so you stop leaking your real resolver. Before you attach it to any Instagram account, run the verification steps from this video. Visit IP info. IO through the proxy. Confirm the org shows a real Singapore carrier. Run a DNS leak check at dnsleaktest.com and verify the sticky session by checking your exit IP twice 10 minutes apart. That test takes 30 minutes and tells you whether your foundation is real before you invest in setup. One proxy per account. Configure it before the first login. Warm the account for 14 days. Stay within the behavioral limits. The bottom line, the proxy removes the network red flag. Your job is to not create new red flags on the device and behavior layers, and that is entirely in your control.